That red means it's recording. Okay? And you just try to follow me around. And we're going to learn about the motion of the moon. Have you all noticed it's a full moon right now?
Yes.
Yeah? We're going to turn the lights out a little bit to do this. We're going to set up the sun over here. This lamp will be the sun. This lamp's not really as bright as the sun, y'all. But just so you can see. Man, this thing's tangled. Here we go. Okay. So we'll plug this in, and this will be the sun. See, the sun is shining. Put this up here a little bit. So there's the sun shining away. Now we need the Earth and the Moon. Luckily, I have a model of the Earth and the Moon.
Wow. Really cute. Yeah, the moon's kind of adorable.
Now, the moon, these models are not perfectly accurate. So you need to think about the accuracy of these models as we're doing these demonstrations. So, I'm going to show the moon going around the Earth, like this, okay? The moon is really not this close to the Earth. The moon is pretty far from the Earth. And the moon is really not this big compared to the Earth. The moon's about half the size. If the Earth was this big, the moon would be about the size of my fist. Or about the size of a tennis ball. This moon globe is a little bit bigger than the actual moon is.
It's really, so it's small?
The moon is, well, it's not small. It's about the size of my fist compared to the Earth. It's way bigger than, like, this school is, or bigger than we are. So I wouldn't call the moon small, but it's definitely not as big as this model shows it compared to the Earth.
Okay.
Does that make sense? And the moon orbits the Earth. And how far is the moon away from the Earth? It's not this close. I'll show you how far it is away from the Earth. If the moon were right here, if the Earth were right there, the moon would be about right here.
Wow.
Okay? That's how far the moon is from the Earth, and if this model were correct. Think about that. We launched several rockets that went to the moon and carried people there. It took about 2 days to get from the Earth to the moon, going 16,000 miles an hour. And you know the moon is moving, right? So you can't just shoot people in a rocket at the moon. You got to leave the moon, and the rocket has to end up where the moon is in 2 days. And if you miss, you just fly off into space. Because they use the gravity of the moon to slow the rocket down and get it orbiting.
Has that ever happened?
Nope. Because NASA guys are good at math. Yeah. And you could also steer those rockets. They had pilots that would make course corrections so that they didn't miss. Isn't that good?
Yeah.
Smart.
That's good.
Smart to have a guy flying the thing. But computers did most of the flying. Have you ever seen the movie Apollo 13?
Yes.
Heck yeah.
Kevin Bacon?
No, is Kevin Bacon in it?
Yeah, he's in it.
Is he? Okay.
Yeah.
Tom Hanks, Kevin Bacon.
So, by the way, BTW, I've got movies here
Oh, yeah.
that you can rent and watch if you want some extra credit. Like, let's say you made a 70 on that quiz and you want to get 30 more points to make it 100. You can rent one of these movies and watch it.
You mean you want money?
No money. You just check them out. You sign them out. Sign them out right here, and you can take them home and watch them. What movies are there?
Oh, October Sky is such a good movie.
Apollo 13.
Ooh.
If you've already watched it, can you say you
October Sky.
You probably need to watch it again because the quizzes are pretty specific.
Okay.
After you watch it, you come take a quiz over it, and if you pass the quiz, I'll give you the points.
That's nice.
So, 2001, A Space Odyssey. The Astronaut Farmer. He's a farmer. He's an astronaut. Total Recall. The original. The Right Stuff. That's about the first astronauts. That's a good one. That's a long one, so I'll give you more points if you like that. Mission to Mars. Gravity. Love that one.
That's a good movie.
Yeah, that's really good. Contact. And October Sky. And we might be getting more movies as the year goes on. So they're all under here.
The Martian.
You take it, you sign it out, you can watch it this weekend, you can come back, you take a quiz, I'll give you an extra 30 points, from 20 to 30 points, depending on how well you do on the quiz. So, so Apollo 13 is about the astronauts that went to the moon. What did I do with the moon?
Put it over there.
I've lost the moon. They went to the moon, and on the way there was an accident, and they had to come back, and there were all kinds of problems, so I won't tell you how it ends, but really good movie. So, anyway, if you want to watch that. So, we've sent humans to the moon. Handful of humans have walked around on the moon and came back to tell about it. You know the name of the first guy who ever walked on the moon?
Neil Armstrong.
Neil Armstrong. Yeah. He said, that's one small step for man, one giant leap for mankind. Everybody was watching. 1969. I was one. I don't remember it. Mom said that I watched it though.
Sure, it all began.
Anyway, pretty incredible that we've done that. But so, what you need to understand is why the moon has different phases. Right now it's a full moon. So why is it a full moon? It's because the moon is in this position relative to the Earth and the Sun. So if that's the Sun and that's the Earth, the moon is over here. So the light from the Sun is shining on the face of the moon, and you can see the whole face all lit up. Here's an interesting question. At any one time, what % of the moon is lit? Is lit up, is bright. Anyone know?
25, 23%. 35%.
You guess.
18%.
27.
64.
Somebody must have 100.
38. 33. 34.
Okay, Amir got it right. It's 50% because the sun shines and only half the moon is lit. Right? Half the moon is always lit. The other half is in the dark. Same with the Earth. Half the Earth is in the light, the other half is in the dark. It's 50%. Isn't that an interesting question? So, remember, when you're looking at this model, this half, the half pointed toward the sun is bright, and the half pointed away from the sun is dark. Does that make sense?
Always?
Always.
Is it always the same side?
It's not always the same side. I'll show you why. Okay. So, because the moon actually turns, so different parts of the moon get lit. The moon turns very slowly though, and so the same face of the moon is always pointed toward the Earth. There's a reason for that. It's called tidal locking, and we're going to study it later. I don't want to get into it now.
Does it have anything to do with tides?
It does. It has to do with tides. If the moon were in this position, you know what we would call it? It wouldn't be a full moon. You know what we would call it if the moon was over here?
An eclipse.
Sun, moon, Earth. Not necessarily an eclipse, because the moon could be too low.
A blue moon.
Actually be
A
right
blue
in the
moon.
Overwinding? New moon.
That's a new moon, meaning the back half of the moon is lit by the sun. And this half of the moon is not lit. So you can't see it. That's called the new moon, and that is this situation right here. That's what they're showing this outline here, but really you wouldn't be able to see anything. We call that the new moon. Y'all ever heard of that? And the moon will gradually go around like this. You know how long it takes the moon to go around the Earth? A month. That's why it's called a month. It used to be called a moon. And they shortened it to month because month sounds stupid. So it takes 1 month for the moon to go around the Earth. Now it's actually, if you measure it out, it's 29.5 days. So the months have kind of been changed by different rulers and whatever. Julius Caesar changed around the months to whatever he wanted. But the original idea of the month was 29.5 days going around the Earth. Yes?
Is there so there's a new moon every single month?
Every month there's one new moon and one full moon.
I feel like I've never seen a sky without the moon in it.
Do you see can you see the outer layer? You just can't see it, right? Or you just can't see it at all?
You won't be able to see it at all because, think about it, if you're sitting here on the Earth and the moon is in the same general direction as the sun, it's going to be the middle of the day. You aren't going to be able to see the moon, you see the sun. It's light, it's daytime. You see what I'm saying? And the moon is not shining because all the light is bouncing off the opposite side of the moon, and so you see the dark side, and it's not bright, so you can't see it. You can't see the moon in the daytime very easily, especially when it's almost in the same direction as the sun is.
Does the moon spin a lot?
It spins around once per month.
That's why you can still see it.
We call that tidal locking. What's that?
You can still see it at some points in the day. It's just
Some points in the day. So let's move to a different portion. Let's say the moon goes around like this, and now the moon is right here. Now, from the Earth, what are you seeing?
A crescent.
When it's right here, 90 degrees, are you seeing a crescent?
At 90?
first quarter.
Yeah, 90 degrees. You would see what's called a first quarter moon, which looks like this. Like
Down at the
this.
bottom.
Does that say first quarter? I can't read it.
Maybe it does.
Mm-hmm.
No clue.
Half the moon is lit, as seen from the Earth. So it's right here. Does that make sense? So it goes from here, where you can't see it at all, to here, where half of it is lit. You're looking from the Earth, you're looking at the moon. This half is going to be lit, the half facing the sun. Does that make sense? And you can see it in the daytime. If you're standing here on Earth, let's get St. Simon's over here. Here's St. Simon's. We should get a little pin where St. Simon's is. I'm going to borrow your pen, Part 3. There we go. Here's where St. Simon's is. Are you in the daytime or the nighttime here on the Earth if you're pointed like this? There's the sun. That's the daytime. If the moon was over here, could you look at the moon and see the moon in the daytime from here? You most certainly could. So you can see the moon in the daytime when it's a first quarter moon. If the moon was here and it was daytime, could you see it? Because it's on the other side of the planet. You can't see it when it's a full moon in the daytime. Now at dusk, as the Earth turns, now you can see it. But you're right on this is the day on this side, night on this side. You're right on the line there. So at dusk, that's when the full moon rises. The moon is not actually moving, the Earth is turning. So can't see the moon, can't see the full moon, can't see the full moon. Oh wait, I can barely see the full moon. If I'm looking along the horizon, it looks like the full moon rises. The moon is not moving, the Earth is turning. Does that make sense? Try it tonight. As the sun's going down, as the sun goes down. Remember that song? There you go. Who sings that?
I don't know.
Kenny Chesney?
Possibly.
Possibly? Yeah.
I think I saw that last night.
The moon rising?
Yeah, and it was like orange and red at first.
Yeah.
And then like as it got higher, it started getting lighter and
That has to
lighter.
do with you're looking through the atmosphere. And as the light from the moon goes through the atmosphere, a lot of colors get filtered out, and you see it kind of reddish looking.
Mm-hmm.
And as the Earth turns even more, now your night, then the moon rises higher and higher, and eventually you'll be just pointed right at the moon, and then it'll be real high in the sky, right above your head.
So the moon isn't moving at all during that?
The moon does move a little bit this way. The moon continually moves this way. But over the course of one night, it only goes about that far.
Oh.
But if you added up those nights, it would be all the way around in 30 days, 30 nights, or 30 days. Does that make sense?
Mm-hmm.
Jack's nodding. He's got it. Okay, so full moon, quarter moon. It's actually a half. You can see half the moon. You know why they call it a quarter moon? Because it's a quarter of the way through the cycle. 1/4 of the way through the cycle. Then if you get all the way on this side, you got a full moon. And then if you get all the way around here, what do you have again?
Another quarter?
Or last quarter.
It's the third quarter.
Oh. That
Yeah.
was the last.
Last quarter or third quarter moon. And you can see half of it again. And that's what it's saying there. Does that say last quarter?
I have no clue.
I can't quite read that. And then you're back here. And you're back to new moon again. But you got to think about it as you're seeing it from Earth. Does this make sense? Now, let me go down a little bit. There's a new moon. See on this new moon, see right there, you can barely see a little bit of light. The sun is behind the moon and is shining on the opposite side of the moon, but you can just see a little bit of it because the moon's a little shifted to the left. So the moon in this case would be a little like this, and you can just see a sliver of sunlight shining on the moon. As the moon moves a little further, you get what's called a crescent moon. Let's take a look at a crescent moon. There we go. See a little crescent? You're just seeing a sliver.
The waning.
A crescent moon is just a little bit of a moon. If you tell a kid to draw the moon, they'll probably draw a crescent moon. They'll draw something that looks like that. Right? Because you're only seeing part of the moon. Think about it. If the moon is right here, or right here, and the sun is there, the sun is mostly shining on the back of the moon, but from the Earth you can see a little bit, if it's right here, you can see a little bit of a crescent where the light is hitting. Crescent moons can be seen, just kind of a sliver, and you can see them in the daytime if they're over far enough. And then you can see them at night. Let's see how you would see this at night. So here, if the moon is in this position, it's going to be a crescent, right? But if, here we are on St. Simon's, if the Earth is turning, this is daytime, daytime, daytime. Now we're getting into nighttime. Nighttime, so it's nighttime here. I can look down the horizon and see the crescent moon kind of sitting on the horizon. At night, the crescent moon is always on the horizon. It's not high in the sky. Because you have to look down the horizon, because it's, now you're at nighttime. So the sun is over there, the moon is here. You can't see the sun, so it's nighttime for you. But you can see the crescent moon, which is over here to the side like this. You see what I'm saying? The crescent moon will be right overhead at 3 p.m. 3 p.m., that's afternoon, the crescent moon will be right overhead. Yes?
Are the different phases of the moon, do people on different sides of the Earth see them at different times?
Yes. So, you can only see the full moon, well, you can only see the full moon at midnight. So, midnight for us is different from midnight for China. So, for instance, so if here's the moon over here, can I borrow this? Thank you. Here's the moon over here. Here we are in St. Simon's. The Earth turns toward the moon.
Hi everyone, sorry for the interruption. Just to let you know, the ambassador meeting today will be at 1 in the athletic conference room. Thank you.
So when we reach midnight on St. Simon's, this is midnight because we're as far away from the sun as possible. That's when the full moon is brightly overhead.
Mhm.
At that time in China, it's not midnight, it's noon. So China's got to wait to go around until it's their midnight to see the full moon. So, but whatever point the moon is right overhead is midnight for a full moon. So let me ask you this. When would first quarter moon be right overhead for you? What time of day, according to this chart?
6 p.m.
At 6 p.m., first quarter moon will be right overhead. So let's find first quarter moon. You tell me. I'll start walking around with the moon. You tell me when to stop when I get to first quarter. It's fun to do this.
Stop.
Now in first quarter, right? So here we are in St. Simon's. Here's the pin. Here's first quarter. So this is noon. The Earth is turning. 1 o'clock, 2 o'clock, 3 o'clock. It's right overhead. Right? 4 o'clock, 5, or I'm sorry, 6. I got the wrong time. So I'm sorry. Here's noon. 1, 2, 3, 4, 5, 6 o'clock. It's right overhead. 7, 8, 9, 10, 11, 12. Midnight. On midnight, where would the first quarter moon be? Where would you have to look to find it? Would it be right over your head?
No, it'll be...
Here's the first quarter moon over here. Where would you have to look? Can y'all figure that out?
What do you mean?
Here we are in St. Simon's. In which direction would you look to see a first quarter moon at midnight?
Yeah.
West.
You'd look west. Look west, young man. Remember that? Yeah, if you look west, on the west coast, you would see the first quarter moon just about to set. And as the Earth turns a little more, it sets. Now you can't see it at all. Isn't that cool? She figured out where to look to find the first quarter moon.
Oh, thank you.
How'd she know that?
Atta girl.
She's using the chart. If I gave you this chart on a quiz, could you use it to figure things out? Let me tell you, there's another word you need to know. It's gibbous. Gibbous means you can see more than half the moon. So when the moon is in this position, it's full. But when it moves a little bit here, it's gibbous. You can see most of the moon is lit, but it's not all lit. It's only fully lit when it's in this position. But when it's here, it's not quite fully lit. This half is lit, and you can't see this other half over here. You can see most of the moon lit, and then you can see a little bit not lit. That's a gibbous moon. So a gibbous moon is more than half lit. A crescent moon is less than half lit. Make sense? Now, the other thing you have to know about the moon is when it's waning or waxing. Waxing on top, waning on the bottom. You know what those words mean? Anyone? What's waxing mean?
You can see it from the far side.
Nope. Good guess.
Waning,
Can you tell by this
waning
what
means,
waxing means?
Waning means it's going away, right?
Waning means it's going away.
And then waxing means it's
Just like getting
come.
brighter.
So it's getting less and less visible each night. So here's a full moon. As it goes this way, you're seeing less than a full moon each night. A little bit less of the moon you can see each night. So it's waning. All along this side, it's waning. Getting less and less moon, and now you don't see any moon. Now it's new moon. And then it starts getting bigger each night. It's waxing. Waxing means getting bigger each night. Waxing, wax on, wax off. Like Karate Kid. Waxing gets bigger and bigger each night. It's waxing, it's waxing. It's now full. It's now waning gibbous. Waning gibbous. Waning gibbous. Third quarter moon. Waning crescent. Waning crescent. Waning crescent. New moon. Waxing crescent. Waxing crescent. Waxing crescent. First quarter. Waxing gibbous. Waxing gibbous. Waxing gibbous. Full moon.
Hey.
Does that make sense?
Yes, sir.
Can you make sense of all these words? Just think, before this day, you didn't understand why the moon looked how it does at different times. You had no idea. Now you know. That's what learning is about. And you know what's cool about this? Nobody else in the school knows except the ones that are taking this class. It's fun to know more than them. Isn't that cool? So, the last thing that's kind of hard to understand is the synodic month versus the sidereal month. So, you know how long it takes the moon to go around the Earth? I told you already. Do you remember?
Month.
Oh, a month, which is how long? How many days?
29 days.
29.5, but that's really not how long it takes to go around the Earth once. That's how long it takes to go through a full set of phases. It actually goes around the Earth once in 27.3 days. But since the Earth is also moving around the Sun, it has to travel a little bit extra to get back to the phase. Just like with the solar day and sidereal day. Remember reading about that? The Earth has to spend a little extra to get back to the noon the next day. The moon, because the moon is going around the Earth, but the Earth is also moving, the moon has to go around a little extra to get back to the phase it was before. And that extra amount takes 2.2 days. So the moon goes around the Earth in 27.3 days. That's called a sidereal month. But it has to go around a little bit extra to get back to new moon. That's an extra 2.2 days. So it's 29.5 days to go around and then go back a little extra to get back to the new moon phase. That was a lot. Can you handle that? The reading is pretty short.